Okay, take down this problem. Determine Y bus matrix for the data given below. Okay, bus numbers they are given from 1 to 2. Okay, resistance in per unit is given, reactance in per unit is given. So what it is given means from 1 to 2 resistance is 0, reactance is 0.2 per unit. 2 to 3 0 reactance is 0.1 per unit. 1 to 3 0 and reactance is 0.3 per unit. 3 to 4 0 and reactance is 0.4 per unit. 0 to 1 0 and the reactance is 0.6 per unit. 0 to 3 0 resistance is 0 and reactance is 0.8 per unit. Okay, so from this whatever the data given, we need to formulate the bus okay diagram. Okay, diagram. So what say for example, sometimes directly this bus diagram will be given. Sometimes only data will be given. We need to formulate very simple. Okay, because almost all thing is given. So 1 to 2, 1 to 2, what is the reactance? So reactance. So here you need to formulate Y bus matrix. So so Y is nothing, Y or Z is nothing but 0 plus J into reactance. Okay, 0 plus J into reactance. Or say for example, Z is equal to 0 plus J into reactance. Okay, Z is equal to R plus J into X. Okay, R is not what 0. Reactance is what X. Okay, so Z is equal to R plus J. So 1 to 2 is nothing but 0 plus J into 0.2. So that's what simply they have kept as 0.2. So 2 to 3.1. 2 to 3.1 similarly. So 2 to 3, 0 plus J into 0.1. Next to 1 to 3. 1 to 3 is what 0 plus J into 0.3. Next 3 to 4, 0.4. 3 to 4 is 0.4. J into 0.4. Okay, next step 0 to 1. 0 to 1 is self-impedance. 0 to 1 is J into 0.6. Next 0 to 3 is J into 0.8. So from this easily, so you can write as Z is equal to Z1 2 is equal to Z1 3 is equal to Z2 3 is equal to Z3 4 equal to. Like that you can easily write. Okay. Next, so how to formulate the Y bus matrix, you know. So whatever the, say for example, Y11, Y22, Y33, Y44. So here Y4, here mistake is there, Y4, this Y4. So whatever the node is joined to this node 1, node 2, node 3 and node 4. You can take some reference. Okay. So node 1, node 3, node 3 and node 4. Okay, so whatever the impedance joining in the node 1, that is nothing but Y1. Okay, so Y12 is what? Minus of Y1. Okay, so Y12 is nothing but general formulation Y12. But here, as per the problem, it is minus of Y1. In general formulation, also minus of Y1. Okay, next Y33 is minus of Y1. Next Y minus of Y14. But Y14 it is 0. Okay, it is 0 because no connection. It is 0. So Y11, how to formulate Y11? Say what are all the nodes joining in what are all the impedance joining in the node 1 that you need to add. Simply you need to add. So what is there? Y10 is there, Y12 is there, and Y13 is there. Okay. So next Y1 minus of Y1. Minus of Y12. This is a minus of 1. So here only Y13, only one thing is there. So minus of Y1. So Y14 also you can write here, minus of Y14, but value is 0 because no connection. No connection because no connection between 1 and 4. So value is 0. So similarly, you have to formulate for Y minus of Y12. Y12 is minus of Y12 or Y21. Better you go for Y21 itself, minus of Y21. So here what is then Y22 is nothing but Y12 plus Y23. Y12 plus Y12 plus Y23. Okay, because Y22, how many impedance are joining here? Y12 and Y23, only two. So here two. So next minus of Y23, that already minus of Y24, but Y24 no connection, so 0. That's all. Next Y31, okay, Y31 minus of Y31 minus of Y32. Next here Y33, whatever joining in that no, 3, node 3. So three connections are there. Four connections are there. Three and one self also there. Four connections are there. That is nothing but Y30 first self impedance. Next Y31. Okay. Next Y32. Next Y34. Okay. Next here minus of 3, 4. Okay, so similarly, Y41, Y41, but no connection 0. So Y42 also no connection 0. Next Y minus of Y43, minus of Y43. Yeah. Next minus of Y44. Sorry, minus of sorry, this is not minus. This is the this okay, diagonal elements, no. So 4, that's all, no minus. Okay, so 4 is what? Yeah, 4 is only one thing is there. Only one thing is joining here. So that is minus of 1 divided by j. So here y1 divided by means all the okay values are given in the impedance. So you need to take the 1 divided by. So z is equal to 1 divided by y. Okay, that's all. So whatever the values here you taken, that you need to take it minus of sorry 1 divided by the j. Y10 what? Y10 what? So Y10 is self. So 1 divided by j 0.6. So Y12 is what? Y12 is j into 0.2. J into 0.2 plus Y13 is what? Y13 is nothing but j into 0.3. In some, if it is given in the 5-mark question, you need to formulate like this. You need to formulate first general. If it is not given, if say for example in Gauss-Seidel method, first step is to calculate Y-bus matrix. Directly you can go for. Okay, no need of making this formulation because time concern. Directly you can go for whatever the impedance joining here. Directly you can go for 1 divided by that value. That's all. Okay, and here half diagonal elements minus of 1 divided by that 1 to 2 means minus j into 0.2. Like that, directly you can go for time saving. Otherwise, you need to, if it is asked in the 5-mark question, you need to formulate like this, then you need to go for. Okay, that you need to understand. Okay, based on the time, if your 10-mark question is asked, the Gauss-Seidel method or Newton-Raphson method or fast-decoupled method, then you should not do all this formulation because it will be time consuming. Okay, next similarly y minus of y13 and here no connection. Y14 no connection, so 0. So similarly y12. Okay, y12 plus y23 minus of y23. Okay, that value. So y23, what is the j into 0.1. Okay, directly like that you need to write. Next y31, 321. Okay, j into 0.3. Okay, next y32, j into 0.1. Okay, so like that you need to and over here for Y33. Okay, 3 connection plus 1 self. So 4 connections are there. So just 1 divided by that values. What are all the impedance connected to that particular node 3 that you need to write here. Again, or otherwise by the formulation also you can write. Okay, or directly if you write, you can save the time. Okay, okay. So 1 divided by j into 0.8, 1 divided by j into 0.3, 1 divided by j into 0.1, 1 divided by j into 0.8. Like that you can formulate. Next y34 is 3 to 4. 3 to 4 is minus of 1 divided by j into 0.4. Next here. So here no connection. Y41 is no connection. Okay, 4-1 is no connection. 4-2 also no connection. Okay, minus of Y43 and minus of Y34 is almost same. So same thing you need to write. Next Y44. Y44 is what? Y44 is nothing but only one. Yeah, it is j into 0.4. Okay, simplifying all these things with your scientific calculator. Okay, so you'll get the values like this. Okay, 1 divided by j into 0.6, 1 divided by j into 0.2, 1 divided by j into 0.3. Like that in scientific calculator, if type in the equal to, then automatically directly you'll get the answer like this. Okay, y bus equal to some values you are getting. So this is of the first problem. This is the answer for the problem, whatever given in the formulation here. So formulate the y bus matrix, okay, shown in the figure here, and write the elements of y bus matrix by using the direct inspection method. Direct inspection method. Okay, some they have given directly the what they have given directly the diagram itself. Okay, some nodal diagram they have given. So what they are asking is they asking to formulate the y bus matrix by using the direct evidence method. Okay, so here some circuit diagram is given. So you're having two current sources. Okay, but what is the general formulation? What is the rule is that first you need to mark the nodes. Step number one. Okay, solution is first you need to mark the nodes. How many nodes are there? Here one node is there, two node is there, three node is there. So sorry, one, two, and three. The three node is there. This is you can take it as zero node. Zero node has no value. But if you want, you can take because okay. So this is you can that is the reference node. Reference node that you can take as zero node, or otherwise you don't take also. It will not make much impact on that. So 1, 2, and 3. 1, 2, 3. Three nodes are there. So first you need to mark the nodes, and the current source is open circuited and voltage source is short circuited. So this you need to remember. Okay, this thing you need to remember exactly. So why? Because this is the general thing. So whatever the current source is there, you need to open circuit. Whatever the voltage source is there, you need to short circuit. So here arrow mark is there. Arrow mark is nothing but current source. Okay, so voltage source means they will keep like this, like sinusoidal like this. Okay, so voltage sources they need to make the sinusoid. Okay, so like this. So voltage source. This is called voltage source. Okay, so they will make the voltage source like this. Okay, so this is the voltage source. So current source means they will keep like this thing. Okay, the arrow mark is nothing but current source that you need to remove. Okay, so current source is open circuit and voltage source is short circuit. Okay, so here it is open circuit. Okay, so first step is mark the nodes and the current source open the short circuit. Okay, so that you need to next step. Here, yeah. So Y bus formulation, what is the generalized term? Y11, Y12, Y13, Y21, Y22, Y23, Y31, Y32, Y33. This is the generalized term. Okay, generalist for the Y bus man. So node, how many nodes are there? There are three nodes are there. So first you need to type 1, 2, 3, 1, 2, 3. So with that you can easily formulate this Y11, Y12, Y13. So similarly Y33. Up to that you can form. Next, what is Y11? So Y11 already I have said. So whatever the thing that is connected to the node 1. Okay, that you need to add just all. So how to add here direct admittance value itself directly given. So no need of 1 by. Okay, so value itself given. So you can easily add that is minus j that is connected to node 1 minus j into 10 minus j into 0.5 minus j into 20 ohms like that. So 3 is connected to y 1. Okay, this particular node. So that you can easily okay formulate here. Okay, next step. What is y12? Y12 is nothing but y12 minus j into 0.5. Okay, this is the y 12. So minus of minus j into 0.5 because y12 is minus of minus. So it is nothing but j into 0.5. What is y13? Y13 is minus of j into 20. Minus of j into 20. So that is nothing but j into 20. Next to y12 and y21 and y2 are similar, same, almost. Next is y22 is what is. So here, what are all the elements joining in the node 2 that you need to add? What are all the elements? Minus j into 0.5, minus j into 10, minus j into 0.5. Okay, that you need to add over here. Next, what is y23? Y23 is nothing but minus of minus j into 0.5. That is nothing but j into 0.5. Okay, so similarly, what is y31? Y31 is nothing but y31 is nothing but j into 20. Okay, y31 is nothing but j into 20. Okay, because minus j into 20 is j into 20. Y32 is nothing but here y23 is nothing but what minus of j into 0.5. That is directly given. So y23. Okay, so y23 or y32. Y33. What are all the nodes joining in the third? What are all the nodes? How many nodes? 1, 2, and 3. So three things you need to add. Minus j into 10, minus j into 0.5, minus j into 20. That you need to add. Okay, so while adding, so as I said, no, off diagonal, no, minus of, but here already minus is there, minus of minus is plus. So here no minus. Okay, so like simplifying, you can easily get the answer like this. Okay, that is minus of j into 30.5, j into 0.5, j into 20, j into 0.5, j into 11, j into 0.5, j into 20, j into 0.5 minus of j into 30.5. Okay, it's very simple problem, 5-mark question. Okay, for undergraduate level, it is 5-mark question. For postgraduate level, sometimes 2-mark question. Very simple problem. Next problem. We will move on to the next problem. So just take down this problem. For the network shown in the figure, write the elements of bus admittance matrix directly by inspection method. So they will give like a directly by inspection method or by direct inspection method. Okay, so like that, whatever, or generally they will tell like for the network shown in the figure below, formulate the bus impedance matrix. So you can go with the direct impedance method. So here, what source is given? It is given as voltage source. So voltage source is short circuit, whereas current source is open circuit. Okay, so first you need to mark the nodes. How many nodes are there? 1, 2, and 3. 3 nodes are there. Okay, 3 nodes are there. First, you need to say step number 1 is mark the nodes. And the current source are open circuit and voltage source are short circuit. So here only voltage source is given. So voltage source, how to identify means sinusoidal symbol like given. So this is the basics. Okay, so it is short circuit. It is short circuited. So if you see here, it is short circuited. Next formulation of Y-bus matrix. Similarly, what I said. So what are all the elements coming from the? What are the elements? So here the impedance values are given. So you need to formulate the admittance matrix. In the problem itself, it will be mentioned. So here it is, they missed it, but here they need to add for the following elements. The following elements are mentioned in impedance. Like that, they will mention. So impedance is given. We need to formulate the Y bus. So Y is equal to 1 by Z. That's all. So what are all the things connecting at the node 1? You need to take it as 1 divided by that values. So one, say for example, how many nodes, how many elements? 3 elements are connected in node number 1. So 1 divided by j into 0.1, 1 divided by j into 1, then 1 divided by j into 0.5. So similarly here, minus of 1 divided by j into 0.5. So here it is 0. Is 0. Why? Because 1 and 1 y13 is not connected, whereas y12 is connected. So 12 is nothing but minus 1 divided by j into 0.5. So this value and this value is same. That is y12 and y21 is same. Or otherwise, if you formulate also, same value will come. That's all. So y22, how many elements are connected? 1, 2, and 3. So 3 elements is connected. That's just you need to add 1 divided by j into 0.5, 1 divided by j into 1. Okay, 1 divided by j into 0.4. Next, y23. Y23 is what? Only one element is connected. One minus of 1 divided by j into 0.4. Okay. So similarly here what is that? Here y31. Okay, y31 or y13 are almost same. Okay, so y31 or y3 is not connected. So here also 0, here also 0. Next, y32. Y32 is what? Is here minus of 1 divided by j into 0.4. Next, y what is this? Y3 3. Y33. How many elements are connected? 1, 2, and 3. Just 1 divided by that values. J 0.4, 1 divided by 0. 1 divided by 0.1. So simplifying this, you will get the answer like this. That is minus j into 1, 3, minus j2, minus j0, minus j2, minus j into 5.5, minus j into, j into 2.5, j into 0, j into 2.5, minus j into 13.5. While simplifying, you will get the answer like this. This is the answer for this problem. This is the answer for this problem given here. Okay, this is the answer for the problem given here. Next step. Similarly, you need to go for the next problem. For the network shown in the figure, write the elements of bus admittance matrix by the direct inspection method. Okay, so here what is there? Here similarly, what is there? Voltage source, you need to short circuit and nodes. That is the step number 1 is mark the nodes. Here 3 nodes, same like a previous problem, only the values are changing. That's all. Values only changing. So what are the nodes connected? What are the elements connected in the node 1 that you need to add? Okay, so here also impedance value is given, just like the 1 divided by 0.11 by j1 1 divided by 0.5. Here minus 1 divided by 1 to 2. Okay, 1 divided by j into 0.5. Here similarly 3 1 no connection 0. Here this same value 2 1 and 1 2 are same. Here 2 2 is what are the elements connected? Here the j 0.5, 1 divided by 0.5. 1 divided by 0.1.0, 1 divided by 0.4. Okay, so here also the same thing. What is the 3 2? Okay, sorry, 2 3 2 3 or 3 2. Okay, 1 divided by j into minus 1 divided by j into 0.4. So here what? 3 1 3 1 no connection 0, 3 1 1 3 no connection 0. Next 3 2 3 2 and 2 3 same, almost same values. So here 3 3, what are the elements connected? That is j into 0.4, j into j1, 0.1, the same thing. So I'll simplify, you will get the answer like this. Okay, that next. Determine the Y-bus matrix for the network shown in the figure below. So this is the thing given. Okay, like what 1 2 0, that is self okay, self admittance values they are given as minus j into 3. Here also minus j into 2, like that self. But here generator values is given. Okay, generator values is given. So that generator values we are taking like this. Okay, generator value we are taking like this. That is okay, 10 j. Okay, it is given in impedance. Okay, so we are taking in 1 divided by that value. That is okay, j into 3.33. So here also it is given in impedance. That is we are taking this j into, because we are directly calculating the admittance. Okay, so here 1 divided by 15 ohms is nothing but j into 7.5. Okay, the rest all other values are same. Okay, rest all other values are same. So here, first, what is the first step? We need to mark the nodes 1, 2, and 3. Okay, just so here you need to remember this. So whatever the generation values are given, so generated values are given in the impedance that you need to convert into admittance. That is 1 by that value. Okay, so that you need to remember all this. Okay, here you need to change. Sometimes problem itself will be given. Sometimes if the problem is not given also, so you can take take that and convert it into admittance value. That is 1 divided by that value. You will becomes the value for this. So here 1, 2, and 3. So here what do you know? So whatever the things joining here, whatever the things joining here. So here one rule is there. Whatever the values mentioned in the voltage, that is nothing but you need to short circuit the values. So if it is short circuit, there is no values. Okay, so directly you can take the values. Okay, so here node 1. Okay, node 1. Directly you can formulate. But in this problem, they solve like this: y11, y11. So whatever the values connected to y11. So 1, 2, and self. Okay, that you need to add, and directly you can tell that. So y22. Okay, so here 1, 2, and self. So that you can add and you can tell answer. So y1, y33. So 3 times. So self is there. Then what are the values connected to node? So simplifying, you will get the value like this. So y44. Y44, you know. No other values. This only minus j into 1.5. So y12 is nothing but minus of that value. Okay, minus of that value, that is minus j into 1.5, that is y. So similarly, y13 minus of j into y13 minus of j into 2.5 is j into 2.5. So similarly, 2, 3 minus of j into 2.5 plus so okay 2, 3 minus of j into 3.5. So 3, 4, that also. So similarly, what you are doing is you are taking the all the value and substituting in the matrix form: y11, y12, y13, y14. Okay, y21, y22, y23, y34, y31, y32, okay, and 3, 3, y34. So like that, y141, y42, y43, k y44. But like just like the substituting, you'll get the y bus matrix like this. Okay, this is the answer for this particular for